process of scientific inquiry is cyclical. Observations about the world around us lead to questions that need answered. Predictions are made and hypotheses are put to the test with experiments. Observations are made. Data is collected. If numerical data is collected, quantitative data, scientists try to make sense of the data by organizing the numbers into data tables. Scientists will also try to create a model of data by creating graphs. All of this is done in an effort to draw conclusions about exactly what the data means. A good graph plots the dependent variable on the y-axis against the independent variable on the x-axis. Remember, the independent variable is the one that is changed or manipulated by the experimenter. The dependent variable is the one that responds to that change. It's the one a scientist measures. A graph will help a scientist determine if a mathematical relationship exists between two variables. Let's examine a few simple mathematical relationships. Let's say a graph of our data results in a graph that looks like this, a line sloping upwards. This graph shows that as the independent variable is increased, the dependent variable responds by increasing as well. So as one variable goes up, the other variable goes up as well. Or as one variable goes down, the other variable responds by decreasing as well. Using your thumbs can help you visualize these relationships. If your thumbs are pointed in the same direction, that indicates that a direct relationship exists between two variables. The dependent variable is directly related to the independent variable, which means a change in the independent variable results in a similar change in the dependent variable. The Greek symbol alpha is often used in science to mean proportional to. What if a graph of data results in a graph with a downward curve such as this? This graph shows that as the independent variable is increased, the dependent variable responds by decreasing. So as one variable goes up, the other variable goes down. Thumbs pointing in opposite directions indicates an inverse relationship between the two variables. The dependent variable is inversely related to the independent variable, which means a change in the independent variable results in the opposite change in the dependent variable. Another way to say this is that the independent variable is directly related to the inverse of the dependent variable. The final relationship we will look at results from a horizontal line after plotting the data. The graph shows that as the independent variable is increased, the dependent variable doesn't change. So as one variable goes up, the other variable remains the same. The independent variable that is being tested has no effect on the variable being measured, the dependent variable. No relationship exists between these two variables. To summarize, a graph of dependent variable versus independent variable that looks like this means a direct relationship exists between the variables. If one of the variables increases, the other variable increases. A graph that looks like this means an inverse relationship. As the manipulated variable increases, the responding variable decreases. A graph that looks like this means no relationship between the variables. Changing one variable will have no effect on the other variable.